showing you how I will be generating some function points for my project here. Let's get going. I have and I'm not sure. I hope you're familiar with function points. I'm First of all, I'll be searching my literature, and my literature is this Pressman book, the software engineers and practitioners approach, which I could recommend very much if you're into software development or for software development in any project. It has a lot of good content here, and as you can see here from the content overview, the content table, we get a very full explanation of each step that is very necessary to understand in order to develop quality software. And this particularly quality is like it's very important to what's it called, to Pressman in this. So it's also the main focus of this book, that we need, that this book is made in regards to creating quality software. So read this if you're interested. Also in any measures of developing software. But I'll be going back to to my track here about function points. I will be trying to find the function points chapter, and this is very handy when you have it as a digital editions Adobe. I don't know if you're familiar with it, but it's like an ebook that you can search in here. So I will try to search for function points. Let's see here. So we get function points here. We get something here, and metrics for requirements model. Let's see again. Just try to research here. So first of all, I'll perhaps be showing you a little bit about how I find the necessary literature for generating these function points. They have to form out a calculation. There's something about it here, but it should be something like a table where we get certain points of function points. Or yeah, we're able to calculate the function points. So here's my semester plan, and in this is from third semester. So there's here my system development teacher made a function point exercise, which we did in school. I did, and this is this was meant for an exercise during class. So I will just try to do something that looks pretty much like this. So you can see here you have some external inputs, external outputs, external inquiries, internal logical files, external interface files. All of these are the function points, and they are in regards to different aspects. As here you can see, they're separated, and they can be counted, and then it can be calculated through these, where we I think we take a qualified decision about whether it's a simple, average, or complex function point, and then we can and I don't know exactly the algorithm or the relation to these numbers. If you divide them, or if you times them by the number of entities with the number here of like a weighing factor, and then get a total, which you then calculate the sum of, and then you'll get the unadjusted function points. And after that's also another part. But let's get to where I was starting. So this, we should have we are here in the book, and I will just try to be looking, because the books has it's where I can find the explanation more detailed. So we got the function points here, although relatively, and it was here somewhere there. So although relatively few analysis and specification metrics have appeared in the literature, it is possible to adapt metrics such as use case points or function points. And and this is interesting, that are often used for projects for estimation and apply them in this context. These estimation metrics examine the requirements model with the intent of predicting the size of the resultant system. So what also, just before we go continue on calculating. You can also just skip ahead if you're not interested in this. But what is necessary to know that it is function points, and as the book states here, yeah, we use this for predicting the size of the system which we intend to build, in a way that we look at we can use this for prediction estimation, so we can perhaps we will be more precise in the size of the incoming system. And this size is sometimes, but not always, an indicator of design complexity. It is almost always an indicator of increased coding, integration, and testing effort. So an indicator of design complexity, and is almost always an indicator of. So in these terms, this should the size is they say that it's a fairly good measure in terms of trying to predict how much effort we will be coding, how much we will be the integration and testing effort. And these, by measuring, and then the book states, by measuring characteristics of the requirements model, it is possible to gain quantitative insight into the specificity and completeness. And this, my dear friends, this is good when you have to tell somebody how are we going to do this, or how much do we need, how much time, how much how much staffing, how much time, how much money do we need for this, or like to get it done with. Let's see here. It's interesting to continue the book. I can recommend it. Let's just we need some more detailed information here to get going in calculating these function points. I think also we found the right chapter. Let me just go back and check here. Software metrics, number chapter 23, metrics and analytics. So I think we found the right chapter here. Let me just check an extra time here. So product metrics, and these are over the past 4 decades, many researchers have attempted to develop a single metric that provides a comprehensive measure of software complexity. So this is and then it says, like, now I'm just gonna give you a brief introduction here. So I'm just scrambling through here. So let's just see here. Characterizes this research as a research for the impossible holy grail. Yeah. So in a way, it's thinking that metrics are complex. Like it's not that it's difficult to generate the metrics, but it's difficult to to make the metrics, like to make them such in a way that you can predict things. That's what we're trying to do. We're trying to estimate and try to find a way how we can predict precisely how we're going to do in a next upcoming project. Although dozens of complexity measures have been proposed, each takes somewhat different view of what complexity is. So it says that you need really a broader understanding of what complexity is. So perhaps not to get confused, or like to get messed up in different ways of viewing complexity, because that's really what it is. It's how we define the complexity, and in a measurable way somehow. So each takes a somewhat different view of complexity is, and what attributes of a system lead to complexity. By analogy, consider a metric for evaluating an attractive car. So yeah, and this is more or less what the book does, just for a brief overview here. But it's like trying to in these aspects where we come to a very, like, it can be very subjective, I think, in some way, or it's very complex to generate these metrics. So, and also with quality, it's very subjective sometimes, or it's very difficult to understand. So the book really is good explaining, giving a real world example of a car or motorbike at least. So let's continue on this. This was just me scrambling a bit. What we're going to do is we're going to look at the here we get some numbers here, so that could be interesting for us to look at. Although many of characteristics appear to be qualitative in nature, each can represent using one or more metrics. For example, we assume that there are NR requirements, number of requirements in a specification. Okay, so this is perhaps not what we need to do. We need maybe to go in a, let's just make a search again here. So I'm just gonna see here. So this is also interesting. Technology product people determines the software quality and organizational effectiveness. Yes, that's also interesting. So I think we found something here. Let me just see. Size-oriented metrics. Let's see. There's another one. Let me just have a look here. So perhaps instead of me going around here, I will just try to see. This is a lot of explanation and how we could do it. I was actually looking for this table like I found before, and I think more or less we should we could see here. We could say that what do we have here? External input. So we did a search for a keyword here. Let's see if it's gonna find anything. External inputs, external outputs. Otherwise, let me just see. No matches found. Okay. So what I will be doing, I think it's weighing. Let me just see weighing. Let me just go back here at the semester plan. So that could perhaps tell us where we have the literature about this. I was just hoping to find it in this book because it's really it has good quality content. So let me just have a quick overview here. So we have some product metrics here. So Pressman chapter 23, that's where we were. Understand the concept of metrics. Using metrics, know what function points are, and from overall perspective, how function points are calculated. Simplifying the complex function point analysis, Ton Meyer on Funder. So this is, let me just see, this is a PDF handout, Ton Meyer. Let me see if I can find it this way. No, let me just have another look here. Simplifying. Yeah, we have it here. Okay, so I don't know if this one answers our questions, but more or less, because I was looking for these weighing factors and perhaps we have it here. All right. So this one is perhaps the best way to get us going here with the exercise. Let's see here. Yeah, it's really good. It's very good explanation here. I'm not sure I read it during class actually, but let's just see here. Perhaps I did, but maybe it's arguably the toughest part of the project is estimating cost and schedule. My wife has always teach me about my ability to estimate. Yeah, let's just estimate when I will leave work, and it being inversely proportional to the importance of me getting home at a specific time. Even the best laid plans. Yeah, we all know that for sure. And a method to madness. Okay, good. Let's go down here and let's just see if we can get some more here. Let's see more terms here. So we have the inputs. Okay, so as we saw in the former slide, we have the let's just get me over here. So I'll just be going smaller, and then I'll be saying here. So you'll get me there. Okay. So what we get here is inputs, outputs, queries all qualify as transactional functions, and yeah, these are important to know. And it's just exercise function point. So what we want is this table. but we also want to understand what we're going to do with this table, because this is just a shell. So inputs, outputs, queries all qualify as transactional functions. And in part 1, I introduced internal files, external files are distinguished as data functions. Okay, so what he's talking about here is these are transactional. So I think some way, I don't know why they use transactional functions, but maybe this happens in transaction. But we have the external here. We have the external output, external inquiries. So these will be inputs. These will be like a form. So let me just see if I can find our project here. So it is, let me just see where we put it. Perhaps, I think it's here. No, it's not. Oh, where do we have it? Let me just check here. See if I can remember the portal. Sure, agreeable. So let me just see here. Sure. Static. Sure. Thankful perhaps this one. No. Sure, because this is impossible to remember sometimes. Red Ocean. No, let me just go to GitHub and let's just check if sign in here. Oh, I'm not signed in. It doesn't happen very often. And I need two-factor login, and my phone is recording us right now. So let me just see. Give me just a moment. I don't know if this is. Let me just check here if we are still on it. Yep. So we're back. So let me just see here. We have some. Here, let me go and then check here. I think it was your repositories. And we have some here. You get all my lovely repositories here. So let me just rando. And I think it is perhaps what do we have here? Rando. This one should do the job, I think. No, this is not. Oh, yes. We just see. Then we look. Okay, so we go to the GitHub. Just technical part of it. Let me have the. Do we have the actions here? Did we push it? No, it didn't. Let me just see. Here, perhaps. We have the. This is the YAML file, but do we have the show web app? Okay. GitHub workflows. Can we get Assure this? Okay, let's just try another thing here. So we go to Paul Assure and see if we have anything here on Assure. So I will just go some different account. Use this one from school and just see if we can get something interesting here. It seems like it doesn't want to sign me in really. Yeah, it did. Oh. So static web apps. Suppose what that would put it. Oh, we're going back here, and then we're just going to the Red Ocean URL. Oh no, don't have the content at the moment. Did I really? Did I full mod? Yeah. Okay. So here we see our project, and so let me just close all these. This so when we consider this, so now we're going to calculating the function points. So let me just have you over here. So when we look at it here, so we're just gonna make a table here. So I'm just gonna go opening a spreadsheet. I think also I have a file about that from the exercise in school, but let me just have it here. So let me just open that. Okay, so perhaps we can keep it that way so we have more space here. Okay, so we get the simple average complex here, and when we so first of all we need to count the user inputs. I hope this is one. I thought I had more, but let's just keep it this way. I thought I had some more actually. Let's just see here. Function points and project magic calculation. Perhaps this one is better. Yeah. Okay. So yeah, this is more complex also. So let me just see if we can use this one. So let's try to use this one. I think it's fairly good. This has a lot of good things in it. So what we'll be looking for here is the introduction. You introduced you to the notion that we have 5 different types of function points, also known as elementary processes: inputs, outputs, queries, internal files, external files. The 5 types of EPs can be grouped into two types of functions: inputs, outputs. Yeah, that was what we did here. So we see before, these groupings are helpful in determining the types of elements that each function is broken down into, to determine the complexity of the EP, and ultimately the number of function points that should be awarded for a given EP. And what do we mean by EP? I forgot that. So what will he tell us about the EP? That perhaps is a good thing to remember. Yeah, that's maybe I should save that for another time. So let's just get going here. And so ultimately broken down into determine the complexity of the EP, and ultimately the number of function points that should be awarded for a given EP. A transactional function is broken down into DETs and FTRs, while our data functions is broken down into DETs and RETs. Time for a little acronym sharing. Okay, super. So DET, data element type, is a unique user recognizable non-repetitive field, and I think if the relation to that is a unique user recognizable non-repetitive field. So I think what he means is that this is an somewhat of a field that is non-repetitive. Okay, and this file type reference is a file type reference by a transaction. A file type reference must also be either an internal or external file. So these are when we say products here, we should get we should have products loading to the page here. So they should come up here on the page. So this is very good. This looks very nice. So what do we have more? We have the okay, and the recorded element type is a user recognizable subgroup of data elements within an external or external file. So so perhaps this is and this is when you get something, could be also from another page, from another database. Great. Now we have and what the clear definition is. This should be this one external interface files, logical files. So they are when you query something, and this is when you get it from another from internal querying, and this is external querying, like you get it from somewhere else. Great. Now it's a quick way of remembering it. So great. Now we have the identified some real things to go count. If you're anything like me, you probably learn this by example. Let's take a real world application, apply these concepts to gain some understanding of how to break down an EP into measurable, countable components. Okay, so now we're ready for the for going into the to the count. So a simple example, let's use a real world example whereby a component of a system that tracks and stores employee information utilized in reporting on job activities. So let's use our example here. So the data elements that will be stored within the system are first name, last name, email, user type. So yeah, first name, last name, email type, user type, username, password, employees, numbers, pay group. Blah, blah, blah. So these are database elements that will be stored. Yeah. For this example, let's assume that all of this data will be stored within the bound of the application you are estimating in a single database file named employee. So I don't have the yeah. So let's just get given this information. This data transaction would be okay. So when he stores here, so let's see here. For this example, let's assume that all this data will be stored within the bounds of the application you're estimating in a single database file named employee. So given this information, this data transaction would be identified as an internal file. So we go to the internal file here, logical file. Okay. So this is what we store. So we know that we need to count the number of DETs and RETs. So we go back here and see data element type is unique user recognizable non-repetitive field. Okay, so this is in the database. So a field where you have the it's unique, yeah, unique, and then we have the FTR or RRTs. So this when we record element is user recognizable subgroup of data elements. So this is supposed, I think it's when we type it in. I'm not sure, but let's dig deeper into it to determine the level of complexity of this data function, which will then identify for us the number of function points to award this file. So we know that we need to count. Okay, so we look at the function point, and then we split it up and then count the subcategories or the categories. These there are 11 DETs and 1 DET for each of the data elements identified above. How many RETs? Based on the information provided, we can judge that there will be 1 RT, meaning that all 11 DETs will be stored in a single file. Yeah, okay, so this is the file. RET is the file that will be that we will be saving it into. So this is the recorded element type. Okay, so this within the external. Okay, super. We're right first. Yeah. So within the file, and so 1 RET, and there will be 11 RETs will stored in a single file of table in the database. To take this a step further, so what this means is that to take this step, let's say that there were additional requirements to be able to track the history of the employee's comp code after all employees do get promoted. Okay, so he counted all these function points. Okay, so all 11 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 here. So these are our 11 numbers. So So data elements that will be stored within the system. So these are 11 DETs, and this will be stored in one RAT. Yeah, this is DETs for one DET, and we're stored in one RAT. It's a bit confusing with all these RATs, DETs. So to take this a step further, let's say that there was an additional requirement to be able to track the history of the employee's comp code and cost code. To take this a step, let's say that there was an additional requirement to be able to track the history of the company code and cost code. Okay, I'm not sure what the short comp code is. After all, employees do get promoted, change job and such. Given the additional requirements, we would account for a second RAT whereby the comp code and the cost code information is stored in a secondary table in the employee file with the employee number as a foreign key to maintain the relationship of the employee and the employee's comp and cost code. Okay, this is a bit more complex, but let's keep going here. So in this somewhat more complex scenario, there would still be 11 DETs, but now we have 2 RATs. Note that the secondary table would have a third DET, the employee number, but you cannot count this DET twice. By definition, you should only count unique non-repetitive DETs once, referencing the following table provided by IFPG. We determine the complexity of the internal file to be low. Okay, for the either scenario described above. Okay, so one RAT, so 6 or more RATs, average complexity, high complexity. So let's just see here. So a sample transaction function count. Okay, so here we get all the inputs here. So this is a visual representation of this. What we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 here of the DETs. And this count for one RAT. Okay, well, the easy identified fields on the text field boxes like the first name, last name, each field is unique and recognizable. There are 10 of these types of fields on the screen. How about the status indicator? It does get counted as a field DET. So remember this. Remember these if else or these radio buttons or something. Get stores as value in the internal file. Okay, there is also one more element that gets counted in the DET on the screen, and this is the save button. Tapping on the save button actually initiates the transaction, enabling the system to maintain an internal file, sends data to database for safekeeping. So there are a total of 12 DETs, okay, on the screen. So actually, yeah, okay, so this is so interesting enough. So there are 10 fields, and this one status also counts like a field, and also the save button. So we have 12 DETs. Let's think about how many FTRs there are on the screen. If as purposely chose the screen for its simplicity, the data entered based on our limited information of the business requirement suggests that there's only one FTR. All of the data entered relates to information about a single employee in the database. Pod heading. Okay, so let's go and count some of these DETs in our example here. So we have this one. This is a contact form. So we have one here field. So this is all. This is one. So this would be an external input. There would be actually 3 external inputs. How about the inquiries? I think we have the sum of 4 DETs because we have to the send button has to be there also. And then we get a one logical file. So it's saved into a logical file. So we get one. Yeah, that should be it here for this one. So let's just go on here with the example here. So I think I'm going to pause now, and then we're just gonna continue in the next part. So stay tuned here. I'm just gonna pause it. So let's go for another part afterwards. Thank you.